There we go. So, anybody have any questions from what you've been studying? You should all be all the way to, I didn't look that close, chapter 7. You're pretty much getting to the end of chapter 7.
Yeah, I think so.
Yeah, chapter 7's a monster. You know, that's when you start getting into a lot of the math. You know, out of this book, I think the lion's share of the book or the material you got to absorb is in chapter 5, which is all of the components and all the how they all work and why you would select them and things like that. And then chapter 7, which gets into you know, putting it all together, designing the array size, designing the system. So what things are you feeling unclear about? I know there you've got to be unclear. You've just had to learn French in a week. So so what thing about this new language do you not feel comfortable with?
Hey Jay, I've got a design question, but I can hold that till later if you want to cover more of what's module content.
Yeah, I'm free and open to whatever. So why don't we get into what you've got, and then it may spur something else from somebody else.
Okay. All right. Well, wouldn't be a Zoom meeting if I didn't say, let me share my screen, right?
There you go.
Because I've been back to back since 8 o'clock this morning. So it's just
one Zoom meeting after another, huh?
Well, welcome to enterprise software, right?
There you go.
Anyway. All right. So one of the things that, and this is just, for the broader group, we had an opportunity to get a quote from an electrical company here in Indiana, Indianapolis, called Jefferson Electric. So they went through and kind of gave me a design template on our system. I mean, everything with inverters, to the panels, to the ground mount system, etc. But the question that I have, Jay, and this is where I need some help. Mm-hmm. So this is the actual property right here that we have down in Nashville, Indiana.
Okay.
Right? And our house is going to sit down here. If you can see my cursor.
Yeah, I can see it.
Yeah. It's going to sit down here in the woods. And then our solar array is going to sit up here in the opening. And this is facing direct south.
Okay.
Right. So the design question, and so panels are going to be here. And then we have our electrical pole, which sits about right here.
Okay.
Right. And that is a pole with a meter. It actually has RV out, RV 30 amp RV connectors on it. They just dropped fiber optics for data a couple of weeks ago. So the pole is here. So from where the pole is to where our house is going to be approximately 675 feet.
Okay.
So we're gonna have a fairly long driveway, right, to get down to the house.
Uh-huh.
So the design question is, where do you put everything?
Oh, that's easy. It's easy.
Because I don't want to run because I'm going to have to run buried lines, and right. I don't want to run 2 buried lines, one for the solar and one for the DC and one for the AC down to the house. So is it we just put everything up top by the panel and then just run one line down to the house?
Yeah, what you're going to want to do is at the pole, you've got the meter.
Yep.
And then below the meter, ideally, and if none of this is installed yet,
no, it's not.
Okay, then put your main disconnect out there on the pole.
Okay.
With a with a panel. I'll explain how my pole is, and maybe you.
Because I remember your system is separate from your house too.
Yeah,
right?
well,
from the Earthship. Yeah,
what you've got is the pole is out there with the meter, and then directly under the meter in the same cabinet even, if you pop open the unit, it's just a box, and at the top is the meter, and then underneath you pop it open, there's the main disconnect, and then there were 4 2-pole breaker connection points under that. So you could actually hook in with 4 different or branch out into 4 different directions from there. So if you put one of those boxes, and it's pretty standard, then from one of those 2-pole breakers, you're going to run to your house. From the other one of those 2-pole breakers, you're going to connect in your solar array.
Mm-hmm.
And then you've got the option with 2 other ones. Maybe you decide you're going to put in a garage or a shed or a barn or something, and you can feed off of that in a different direction if you so choose in the future, or you might never use them. But you can make your connection, as long as you're making your connection somewhere on your side of the meter. That's all you got to do. You don't have to go to your house. The power is going to go to your house automatically.
So where do I put my batteries in? Since we're going to have a battery backup system, do the batteries sit? This is where it gets interesting, right?
Yeah.
Do I actually create a barn or a storage barn or something that my batteries all sit up on the top of the property, so that, you know, the line that goes down to the house, it does, you know, it's the line that it's either solar, it's grid, or it's battery.
Yeah, with the new International Fire Code, you got to have your batteries outside anyway.
Okay.
You're not allowed to put them inside your dwelling unit. So you may as well have them up there as down next to your house. Now that raises some interesting issues because you know, they also have to be temperature controlled in some way. So we're anticipating they're going to have a lot of products out there like waterproof, weatherproof, temperature controlled boxes that are designed specifically for batteries, because this is a new thing. Everybody always just stuck them in the garage, or you know, put them in your basement.
I was gonna say in the basement, right?
Yeah. But they're not going to be allowed to do that. So
interesting.
So there's going to have to be a market out there of. And part of the problem is most of these people making these decisions live in Southern California. So it never occurs to them that it gets below freezing sometimes, you know, or whatever. So they're all living in 70-degree weather year round. So they're like saying, well, what's the problem? You know, well, it is a problem if you live in Fairbanks, Alaska, or something like that, or even Indiana, you know. So yeah, I would look at building. There's another piece of equipment that's going to be part of your system, is an auto transformer, a way of disconnecting from the grid.
Right.
So all of that I would try and put right up next to the pole. You know, come up with and since you're designing this from scratch, you may as well put that all right there. You know, plan to build a little shed or a little.
Well, we actually have plans to put like a 30 by 50 pole barn up in that area. So, but I don't know, I don't know if a pole barn would suffice, or if it needs to be, you know, a fully enclosed shed, even like a storage shed. I mean, I could drop a storage.
I mean, I just had this vision of your pole sitting there, the meter on one side, and on the back end of it, just you know, a 3-foot wide, 6-foot tall, little waterproof thing where you can open up the front and the sides, and it's basically an equipment cabinet.
Exactly. Yeah.
That would have your auto transformer, your batteries, your and your communication device for monitoring your system. Since you said you've got all of that come in and at the same location, that solves a little bit of a problem as far as monitoring of your system. But just build it all right there, attached to your pole on the north side, you know, so it's in the shade, and make it a nice little secure unit. And that would be.
It's almost like it's a little telco room. It's one of those little hardened remote, you know, telco rooms like that you see on the side of a, you know, of a solar tower, not solar, but a cell tower, but something a little more smaller, you know, something.
Yeah. Pour a little concrete pad and, you know, get yourself a little temperature controlled enclosure that's NEMA 3R rated and that's that. Yeah. It's not any more complicated than that. Yeah. We can try and brainstorm what else you might want to put in there in the future, because maybe, I don't know, an electric vehicle charging station. Who knows what you might want to stick up
Yeah.
there.
But so what's interesting though is then how do I do the critical load panel then? Right? Or because this is going to be a passive, high efficiency energy house, we could run, there isn't a critical load panel because the batteries run the house, because we won't have an HVAC system. We're not going to have a furnace. We're
Yeah.
not going to have an air conditioner. I mean, it's going to be a very different
Okay.
type of load for the house.
All right. Yeah. Well, you could even set up your critical load panel. I see that you're dropping off there, Jay. Yeah. You remember you've got 4 breakers up there.
Mm-hmm.
Well, one of them can be your main panel. One can be your critical load panel. And your auto transformer simply disconnects the main, and runs through one of those breakers. So let me, I'm going to throw my whiteboard here so I can just
Okay, cool. Thank you.
Thank you. Draw a picture of what I'm talking about if I can find it. Oh, there it is.
By the way, Jay, where are you? Because you're not at home. Are you?
No.
Are you?
I'm at Zane State.
Are you at Zane State? Okay, gotcha.
Yeah.
I was curious.
Yeah, there it is. Okay. So how do I clear the screen there? This one's weird. I have a different. I know there's a thing I can just say clear the whole screen, but
or you can just add a page. That's another thing too. At the very bottom of the menu bar on the floating on the side, there's pages at the bottom, and you can also just add a page.
Oh, I see. Okay.
Yeah.
All right. So what I'm thinking about is, okay, here's your meter.
Yep.
And you're on your telephone pole somewhere. And then underneath of it here is a box. This is your main disconnect here.
Mm-hmm.
And then let's say you've got 4 double pole breakers here. And
Mm-hmm.
one of these is running off to your house.
Mm-hmm.
And that's going to a panel, which is considered your non-critical load. So let's say that's non-critical.
Mm-hmm.
And then you maybe have another one going off to another panel that is your critical loads. So you're running 2 lines there. This is one option. It may not be your best option because you may have a lot of wire involved there.
Well, it's 650 feet. I mean, it's a lot of copper.
Yeah. And then your auto transformers, is up here,
Right.
and it's going to be connected through this. So the main comes in here,
Right.
and then there's a line that goes here.
Yep.
And a line that goes there.
Right.
And then the transfer switch just simply turns off your non-critical loads. But if it's a relatively small house, and you're willing to do load management, you may as well just have your whole house as critical loads.
That's what I'm thinking. And then we just manually. I mean, the appliance that's going to have the most load is going to be the oven.
Yeah.
And probably the dryer.
And just don't run those.
And we just don't run those.
Or you could also within your service panel that's in the house.
Yeah.
Because now you're going to come in here, and then you're going to have a lot of breakers going out.
You can just flip the breakers of
But
what we're not going to use.
You could do that, but they also have service panels now that can be load managed remotely.
Oh, really?
From your phone.
Really?
So you could actually set up through your phone, through an app that says, when I am in critical mode, simply turn off these breakers.
Oh, that's cool.
And do it. You can even set it up to do it automatically. So, if you could, I don't know what signal it does, but maybe there's even a component where when this auto transformer thing switches,
Mm-hmm.
it can automatically notify your load management system to go into critical load. Because, you could set it for, okay, I'm on vacation mode. So
Mm-hmm.
when I'm on vacation mode, turn off these things, but leave these things on. When I'm in critical, non-critical, turn these, and they can all be different, and it's all managed through your phone. So for instance, let's say you're away from the house the example they always use is, I forgot to turn off the oven or whatever.
Mhm.
You're away from your home and you go, I don't remember if I turned it on or I turned it off. So why not? Let's just turn it off. I'll go on my phone and turn off my oven. So that's nice. Or you get a notification that there's a power outage. And you just go in and with your phone set it to turn off certain loads, like your hot water heater or your dryer or whatever.
Mhm.
So all of
Jay-
that's doable.
Okay, that's cool. All right, so that answers that question. So then the other question I have, for a 650-foot run from, from the system down to the house, how do I calculate gauge of wire in terms of what do we use so that I can start pricing out, and then I've got to, I'm gonna have to pull somebody in to bury the damn thing,
Right.
Assuming that we have a driveway soon, but that's a whole different conversation.
Well, okay, let's do that. What is the issue? Well, the main issue is going to be, first off, amps.
Mhm.
So let's assume that you have 200 amp service coming
Right.
in.
Mhm.
Well, looking up at your table, what is the ampacity rating required for 200 amp service? It's, I think, page 104 of the book. So what gauge wire?
Hold on. Gotta get my book. Oh, and I turned right to the page. Let's see here.
You must have been looking that up often.
Yeah, something like that, right? So 200 amp copper at 75 degrees Celsius. That is the gauge is 3.
3 gauge or 3/0?
3/0.
Yeah, so 3/0.
Hey, Jay,
Yeah.
couldn't you use aluminum because
Oh, good question,
it's a
Ed.
lot
Yeah.
cheaper.
You could, and the utility does, for that. Now, inside your house, you don't want to use aluminum.
Right.
But
I
from
got
the
that part.
pole all the way to there, you could. So what would
Okay.
that be? 4/0 aluminum, maybe? I don't know if I reproduced the aluminum part in the book.
No, I just have copper.
Yeah, so you might end up with 4/0 aluminum, which might be a lot cheaper. So that's an option. Yeah, 4/0 wire or even 3/0 wire running 600 and some feet is pretty expensive. So you don't want to run 2 of those.
Exactly.
Yeah. Okay, so then the other question, that's the size you'd need based on amps. But what is your voltage drop? Well, what is the voltage drop equation? Everybody, voltage drop equals? Okay. This is going to be on the exam.
I'm sure it is.
Anybody can throw this in. Sadiq's just sitting there being a stalker or whatever on the line here. So voltage drop, amps. It's just a variation of Ohm's law, right? Amps times resistance times twice the distance divided by 1,000 feet, right?
Mhm.
Okay, so what are the amps? Well, in this example, it's 200. What is the resistance? Well, what's the resistance of 4/0 or 3/0 copper, depending? I think the resistance table, don't know where that is in the book, 60 something.
Where is that? So this is resistance for 3/0.
Yeah, 3/0.
It is. It is .0630.
Okay, point. So
0630 is what it's,
point, you said it's point.
yeah, .0630.
All right, so that's going to be ohms. And you said the distance was 650 feet.
Correct.
So that's 1,300 divided by 1,000 feet. So now it's going to be 200 amps times 0.063 ohms times 1.3. So taking out our handy calculator, 200 times 0.063 times 1.3 equals 16.38.
Mm-hmm.
16.38 volts. Let me get the right. All right, 16.38. Well, what's the service coming in? Is 240 volts. So 16.38. So it looks like you're going to have relatively significant voltage drop, right?
Mm-hmm. Yes.
6%, almost 7%.
Mm-hmm. 6.8, yeah, or yeah, 6.8%.
Yeah. Now within the grid is operational only at plus or minus 6%.
Mm-hmm.
So you're probably going to have to go with the 4-aught copper, which is going to be
So that's 0.05.
0.05.
Yeah, is the resistance per 1,000 feet.
Yeah.
So then if we take that, so if we take 200 times 0.05 equals times 1.3, that's 13. So that's 13 volts.
Yeah, and 13 divided by 240
is 5.4%.
Yeah,
So you're gonna have to go with 4-aught wire.
Yeah. Now the issue is, and this is something you can double check with them, because I was just trying to think, because this is AC, is it going to be twice the distance or just 1 times the distance? But you face the same issue whether you've got solar or not.
Mm-hmm. Oh yeah, this is
Right.
Yeah.
So
Absolutely.
whatever they're bringing in, whatever wire they're bringing in from the grid to your service panel there at the pole is probably acceptable. You know, you'll have to check with those guys, but with the utility,
Mm-hmm.
because how far can you run using that wire before you have enough voltage loss that it's a problem?
Yeah.
That's what you gotta find out.
Well, and that goes back to Ed's point too, is, can you use aluminum, right?
Yeah.
How close are you to the transformer? Do you know?
Yeah. Well, normally it's on a pole nearby, but
Yeah, I'm trying to remember, Ed, whether the transformer, if we've got one sitting on, I don't think we have one sitting on the pole. The transformer, I want to say, is maybe 100 to 150 feet away.
Okay.
Ish, maybe.
Yeah.
We're going back down on Thursday. I can go look, but yeah, I think that's about what it is.
and what that would affect, Ed, is what's the voltage coming into the service panel, into the main? Because they're already going to be wiring it from the transformer to the main
To
disconnect.
the main, right.
But if it's got voltage drop, and so your power is coming in not at 240, but something less than 240.
That's what I was thinking. That's my point.
Yeah, then that could make the problem even greater. Although oftentimes the power coming in at the main is higher than 240.
Mhm. Yeah.
Like at my pole, at my main, it comes in at 245. You know, so I've got an extra 5 volts, you know, that I could lose in voltage drop there. So if you're coming in at 245, then, you know, you're probably fine. So the first step here is of course sizing it based on the amperage that you're going to be sending through. And is 200 amps, I mean, is how big a house are you talking about? You know,
2,500 square feet.
oh, okay. So it's not a cabin in the woods kind of thing.
No, it's not. No, it's a
real
you know,
home.
It's a real home.
Yeah. Okay. So 200 amp service is probably legit.
Mhm. Yeah,
You're going to be burying the wire, right?
correct.
Yeah. So you're not going to have temperature issues there. Yeah, I'd find out from, well, let me do a quick little internet search while I've got you on the thing. What?
Ollie, are you putting it in conduit?
Yes, he is.
Okay.
There's
Yeah,
no way.
because that is code.
Well,
Okay.
plus you don't want to. Yeah, it's saying for
It
200
has
amp
to be, right.
service, for 200 amp service, you'll need 2-aught copper wire or 4-aught aluminum.
Hmm.
Is just what they're saying. Here. Yeah, 4-aught aluminum is just for 200 amp service. And what is the resistance?
For the aluminum.
Aluminum, yeah, to see.
I would assume it's higher.
Yeah, it probably, yeah, it's not as,
Conductive.
yep, bare aluminum. It's $1.66 a foot. Oh, that's bare aluminum. That doesn't even have insulation. Jeez. 4-aught aluminum 600. Yeah, the stuff with insulation going whole hog, it's $2.35.
Oh yeah, I think when I was running preliminary pricing for copper, it was about $5,000 for a reel of copper.
Yeah. Yeah, welcome to the wonderful world of home ownership, huh?
Mm-hmm.
Yep. Well, my guess is you're going to have to go with, you know, either 4-aught copper or 4-aught aluminum
Yep.
to make that happen. But
Okay.
you definitely have a voltage drop issue. And one of my rules of thumb that I like to go by is basically that if the distance is less than 200 feet, you don't have to worry about voltage drop.
Mhm.
You know, that the ampacity rating for the wire will require that you have wire big enough that voltage drop is not an issue.
Mhm.
But if you go longer than that, further than that, then voltage drop may become the defining factor in what size wire you need, more so than you know.
Well, and that's the issue I have here with that distance for sure.
Yeah. Now they do make wire bigger than 4-aught,
Mhm.
you know, but I suspect it's even more pricey,
Oh yeah.
you know, because it's going to be not really a residential size. It's more industrial size. But
Jay, is it dependent upon the county and the code in terms of how you can trench that, whether you can do it yourself or whether you have to have an electrical contractor do that? Or do you have any?
not generally on your own. Well, first off, it's your own home. So almost everywhere you can do the work yourself.
Mhm.
They do that as a, you know, just as a matter of given, but it's not difficult. Now, how deeply it needs to go is going to be dependent. The National Electrical Code says buried conduit has to be 18 inches deep.
Right.
You're going to want to go deeper than that anyway. Just, you know, for because it's good practice. Plus, if you're going to trench, may as well trench.
Mhm.
You know, and if you've never used one of those trenchers, it's basically looks like a big chainsaw on wheels.
Yeah. It's like a
And-
stump grinder, but with a longer end to it. Yeah.
Yeah, it just has the bar that
Yeah,
goes
yeah.
down into the ground and it digs
Yeah.
it up and it throws all the dirt on one side. So it's
Yeah.
not a big deal. But if you're going through woodlands, suddenly it becomes a big deal because cutting through all those roots is
Well, so what we're doing, so since the driveway has to go in, so we're
Uh-huh.
coordinating with our excavator. So our excavator is gonna go ahead and go through. And then we're gonna come in behind and trench and bury it
okay. Are you going to bury it under your driveway?
under the driveway. Yeah, that's the thought.
No, that makes sense. That makes sense. Is he gonna dig down? Probably not. He's not gonna dig it down and he's just gonna clear it.
Yeah,
Yeah, so you'll have to trench through, but that, I mean, you're gonna hit some roots, but it's not a big hairy problem. Although one of the things I've found with those trenchers is if you do hit a root in a certain way, it'll kick the chain off the
oh,
bar.
wow. Oh, interesting. Okay.
And it's not something that you can just kind of fix yourself,
It's not like on a chainsaw, just popping it back on.
not unless you've got some pretty hefty tools. But that's one of the joys of renting,
Yeah,
because
it's not my problem.
you tell the guy, hey, the chain came off, get me a new one or come out and fix this thing.
Gotcha.
And they'll
Okay.
generally do that. But just something to be conscious of, be aware of. But as I alluded to before, never, even though they say you can direct bury cable, don't do it. Don't do it under any circumstances. It will save you a little bit of money, but it will cause you a great deal of headaches in the future.
Jay,
Yeah.
the reason I asked about it, was it going to be in conduit? Because recently our utility pulled out all the old wires in the neighborhood. They were all buried. And they put it some in conduit between the transformers. And then they direct buried from some of the places where the conduit ran by up to the meters. And I
Yeah.
did notice, while you might be interested in this, rather than
Yeah.
use the PVC, they
Mhm.
had the conduit in spools, like a big spool where you could just,
It's a tube. It's almost like
Yeah.
an orange conduit tube,
Yeah.
right?
right, correct.
Because
It's
they're burying
flexible.
lines in our neighborhood right now, Jay. We live in a wooded neighborhood. So they're
Right.
taking them off the pole. I know it's in the neighborhood. I know exactly what you're talking
The
about.
orange is usually fiber optic, but this stuff was black. It looked like almost like a drain line, like a flexible drain.
Oh,
line.
wow. Interesting. Okay.
And it just
Well-
comes in a big spool, and you could probably run that whole 1,000 foot. You wouldn't have to worry about gluing it and all that nonsense.
Yeah, well, they also, they'll have directional borers too, if you wanted to
Mhm.
avoid the roots, and they can pull the conduit in behind
Yeah,
as they're,
behind it. Yeah.
as they're pulling it. But again, all that adds cost. The advantage of doing it in sections, if you're going to do it yourself, is trying to pull any kind of cable, especially 4/0 cable, 650 feet.
Oh,
through
Jay, you mean it's not
conduit.
like pulling Ethernet? Are you kidding?
No,
Right?
it's-
It's a little heavier than pulling
You
Cat
just
5 or
have to
Cat
hook
6?
up your 4-wheel drive to it. and
It's
start-
heavy, right?
Start
Yeah.
pulling, yeah. So what I would do is trench it, take your sections, they come in 10-foot sections,
Yeah.
and then
Lay
just
it.
feed them through one section at a time.
Yeah.
And then have the whole thing laying next to the pipe or next to the trench. Then glue them together after the wire's already been pulled through.
Yep.
And then just walk your way down, throwing it into the trench. The whole unit down into the trench.
Yeah.
And it makes life a million times easier.
And then
You've done
run
this
another
before.
spare conduit.
Yeah, you could,
Well, Ed, I thought about that. That's a really good point, because this is one of those things you do at once. You don't want to have to go back and dig the damn thing up if there's a problem.
Mhm.
right. And you may find yourself with a situation, let's say we've got a situation right now where if we could get cable for internet, they're not going to bring it back to the house, but they might drop it at the pole. Well, then you've got like you
Well, Jay,
know,
that's another that I'm gonna have to do that too, because they're gonna drop the fiber. They've got the fiber on the pole for the communications. I've got to run it down to the house.
yeah,
So I'm gonna have to have another conduit. For that. So Ed, to your point, I'm gonna have to run a couple of conduit, one for power and then one for comms. But maybe have an extra dormant conduit with a pull string, just in case I need something else.
yeah,
Just make sure it's big enough for
Yeah, right.
anything.
Yeah,
yeah,
right.
yeah,
Don't
it'll
put-
be,
Don't put 1/4 inch conduit or 1/2 inch conduit in.
get yourself 2 inch, yeah. And the cost of it, yeah, okay, so you're gonna spend what? $5 a section. So 650 feet, so you'd have 65 sections. What's that, $300?
About, yeah.
I mean, you know what kind of money you're gonna be racking up. So $300 is
A good
not,
insurance, it's an insurance policy.
yeah. And just terminate it and cap it, bring it up
Yeah.
and cap it off. Yeah. Yeah, and another issue to consider, I know it's not an issue here, but in some places, I was doing an install up in Minnesota, and we had sized what we needed, and we are going to go with 1.5 inch conduit, PVC buried in the ground, and went in to buy the material at the local electricity shop kind of thing, and I said we need 150 feet of 1.5 inch conduit. And he goes, no, you need 2 inch. I was like, no, I don't need 2 inch. I need 1.5 inch. He goes, no, you need 2 inch. It's like, you don't even know what I'm doing. It's like, and he goes, you're bearing electric, right? It's like, yeah. He goes, well, you need 2 inch. I said, no, I measure, I mean, I do this. I know that I need 1.5 inch. He goes, gophers can't open their mouths 2 inches. You put 1.5 inch in there, gopher will chew right through that. And I was like,
Really?
oh,
You learn something
okay.
new every day, right?
Yeah. And he's like, up here, man, you do not bury anything less than 2 inches.
Really?
And I was like, oh, well, okay, then give me 2 inch.
Jay, either that or he just upsold you.
I know,
Hey,
well,
that was the biggest,
it is the
sham of
Gophers.
the year.
It's
right?
the gopher state, so I'll believe him. So, but local conditions, so that's something to consider. But yeah, we ran into the issue, and one of the reasons I'll say don't not put it in conduit. We had a lightning strike in our field, and just lightning hit the ground. Well, it traveled through the ground. The electricity was direct buried, blew apart the neutral in the ground.
Oh, wow.
So simply blew it in half, which then caused the voltages to go imbalanced and blew out some of our equipment in our house.
Oh, wow.
And then it was an $18,000 repair to get that all done, to get it fixed. And it was 400 feet. So to retrench, rebury, fix the appliances, all of that, the insurance was $18,000. Where if that had been stuck in conduit, non-issue. And then, of course, these guys direct buried it again. And 2 years later, a rock or something had nicked through one of the conductors, and I had to locate where the problem was, because basically what it was is the insulation. They had used aluminum, and the insulation had deteriorated where the nick was, and when it got wet, the aluminum would lose some of its conductivity. So the voltage was varying between 120 and 90 on that leg of coming in to the house. So at that point, I wasn't going to call anybody. I just started digging I was going to hand dig 400 feet following the wire. And fortunately, in the first 1.5 foot, I found.
You got lucky.
Yeah. Fortunately, I started at the right end. And so I then turned it all off and did a splice repair, and that fixed the problem. But they should not have direct buried it, especially for $18,000, So anyway, any little imperfection in the conduit or in the insulation will over time deteriorate. and cause you a problem. And the other thing with direct buried is, let's say there's a rock down there and it's touching the wire, and you get a freeze thaw cycle and it starts to just sort of razor wire the insulation, you know, as it freezes and thaws. So put it in conduit. Don't do anything other than conduit. And then when you bury the conduit, about 3 or 4 inches above the conduit, put one of those metallic warning tapes. They just sell them in rolls. It's a metallicized caution tape. Lay it in there about 3 or 4 inches above where your conduit is, then fill it in, and at about 3 or 4 inches below the surface, put a second tape in there and bury that. Now, the advantage there, of course, is if you start digging and you hit a tape, you know that there's something down below. And if you ignored the first one, you got 2 shots at hitting it, which is why 2 tapes is nice. But the metallicized one, you can later trace the line
through a utility locator.
Yeah, using some sort of electrical or a magnetic tracer. Yours is going to be less of an issue if you're following your driveway. You know, you're going to know it's underneath the driveway. But for a lot of folks, I mean, normally what you do is look for that little depression, you know, years later where the thing didn't settled in just a little bit. But sometimes you just lose track and you got to trace them. So take lots of pictures too of the trench when it's open, because years later you're going to forget. And put them in a place where you remember, because now you're going to go up and put a hot tub up next to your pool or next to your pole out there or something. And you're going to, where was that wire? Where did it run? Did it go here? Did it go there? I don't remember. So
another thing, Wally, you can do is when you take the pictures, use a tape measure as a reference point from some landmark, like the edge of the driveway or.
Yeah, that's a good idea.
That's a great point, Ed. Thank you. Yeah, just so that you've got a solid map of it, so you know where it goes.
Yeah. In fact, what you might want to do is as you're documenting the building, because you're going to have a million things that happen when you're building this building, take all of those pictures, put them on a stick, you know, on a thumb drive.
Yeah.
And then file that away somewhere in a safe deposit box or something where 10 years from now, you'll be able to go back and reference it. You know, because you're going to have to remember where the pipes were in the walls, or where the drain was, or where's the septic tank, you know, output from your house, or all of these things that are no longer going to be exposed. And you're just going to need, you know, to document all of that stuff and stick it on a thumb drive.
Yeah, no, that's important. And especially since we're GCing this ourselves.
Oh,
so,
yeah.
So, I mean, we're going to know where every nail is, every screw, every, you know. Even
if you hired an electric or a general contractor, it's like hiring a lawyer. You still got to do most of the work.
You still got to do most of the work. Yeah, I love that. That's a great saying.
Yep. So, yeah, it's always comes down to that.
All right.
Okay,
well, thanks everybody. Thank you for thanks for your time. I appreciate that today.
Yeah. Well, we all expect to be invited out for Christmas.
Oh, you will be. Oh yeah, absolutely. we'll do Yule, Indiana style.
There you go.
So there you go.
All right. Anybody have any questions of a technical? We've talked a little bit about voltage drop. That's one of the equations you're going to have to remember is voltage drop equals amps times resistance times twice the distance divided by 1,000. One of the other equations you're going to have to remember is the power equation, which is basically watts equals amps times volts. Hopefully that's something that's now in your brain. The third equation you'll need to remember is Ohm's law, and that's volts equals amps times resistance. So you remember that if the power equation, I'm going to try your thing where I just do a new page. There we go. That's so much easier. All right. So if the power equation is watts. Whoops.
Oh, I think you've got to share that new page, Jay.
Oh, do I?
Or swipe it. Yeah, because we can still see
the old page.
Oh, wait. No, you know what you do? You just have to move it with your mouse. Where are you? Here, let me zoom out. Actually, if you also zoom out, Jay, on your page, you've got all kind of real estate.
Oh, I see. All
You
right.
see what I'm saying? So you got a huge whiteboard to work with. So if you just zoom out and start somewhere else, then for those of us that are watching, we can just scroll. If we all zoom out, we can see where you're starting, and
All right. I'll just
or
do it.
you can just do it the old-fashioned way, right?
I
Yeah.
know it's like, well, this is like the new Zoom whiteboard. I had like an add-on thing where I could easily just click the erase everything kind of thing.
Yeah.
All right. Okay, so let me get my pen here. And so watts equals amps times volts, right? That's the power equation. That's one of them. Ohm's law is volts equals amps times resistance. All these are relational equations. If you know two of them, you can figure out the third one. And then you'll see that the voltage drop equation is simply Ohm's law adjusted for distance. Voltage drop equals amps times resistance times twice the distance divided by 1,000. Well, this is the adjustment for distance because the resistance is given you in ohms per 1,000 feet. So really voltage drop is just Ohm's law, but adjusted for the distance of the cable run. Yeah, Paul, you've got a question?
Yes, sir. Can you hear me?
Yeah,
Will we have the ability to bring a calculator or any reference material at all?
You'll be able to bring a calculator for sure, and a scrap piece of paper. That's basically it. Everything else
is there?
Everything
ahead.
else is in your mind.
So will there be a lot of formulas on the test?
No, the
Or-
only ones that you've got to remember are these.
These, okay.
Yeah, and everything else will be provided to you. Like for instance, if I were to say, let's say we want to do a question where you're going to have to solve for voltage drop, it will tell you what the resistance is of the wire. It will tell you what the distance is for the run. So that will be provided to you. You don't have to memorize tables, you know, of like, what is the resistance for 10-aught wire, or what is the resistance for 8-aught wire, or whatever. That will just be provided to you. So these are the three equations, pretty straightforward. The only one that's complicated at all is the voltage drop equation, and it's a simple variation of Ohm's law. I just remember Ohm's law by remembering VER, volts equals amps times resistance. Just go VER. Okay, I know VER. I don't have to know anything else. The other thing that you got to remember is that when you're doing temperature string calculations, what's the minimum, what's the maximum of the string, that with the minimum number of panels in a string, you do that on the hottest day ever, and there's a temperature adjustment based on how it's mounted. So a ground mounted system, you add 25 degrees Celsius. For a ballasted system on the roof, you add 30 degrees Celsius. And for a flush roof mounted system, you add 35 degrees Celsius. So those things you just have to know. So where that's coming in is you add that to the ambient air temperature. So remember how we do a string calculation is you would start with the differential between in this case, the coldest day ever and standard test conditions. So if I wanted to know what's the most solar panels I can hook up in a string calculation, let's say I find that the coldest day ever at this location is minus 40 degrees Celsius and standard test conditions is 25 degrees Celsius. Then what is the temperature differential between that, the delta? In that case, it's going to be 65 degrees Celsius. And then we take 65 degrees times, and then you'd look up what is the temperature coefficient for that particular panel. So let's say we've looked it up on the panel spec and it's 0.3% per degree Celsius. That's the temperature coefficient at VOC. And you'll get that from the solar panel spec. So in this case, we take 65 degrees. So it's going to be 65 times 0.3. So it's going to be 19.5% because the degrees Celsius cancel out. So basically in this scenario, if it's minus 40 degrees Celsius, it's saying that panel will generate 19.5% more voltage than it would generate under standard test conditions, because the temperature coefficient is how much more voltage will it generate for every degree below standard test conditions. So if the VOC on this particular panel were, let's just say 40 volts is the VOC. So I'm just saying the VOC equals 40 volts. So I would take that times 119.5%, because I'm going to get 40 volts plus 19%. So it would be 40 times 1.195, 47.8. So on the coldest day ever, that panel might produce 47.8 volts at that particular location. So each panel would do that. Well, then we find out, let's say our inverter has a maximum 600 volts. I would divide that by 47.8 volts, and I would get 600 volts divided by 47.8, 12.55. And since you can't buy part of a panel, we're going to round it down. So 12 panels max in each string. Everybody remember that? You've gone through those kind of equations and done them? It's basically what we're saying is if you've got a 600 volt limitation on your inverter, and these are the specs, and this is the temperature at that location, then the most you can hook up in a string and not exceed the input limits of the inverter is 12 panels. So on the worst day of the worst day. With the least panels, we do the same kind of thing, only we use the hottest temperature. We use the startup voltage of the inverter, and then we have to add in 25 degrees, 30 degrees, or 35 based on how the thing is mounted, because panels are hotter, you know, than the ambient air temperature. And it depends on how and where they're mounted. So I'm not going to go through that equation, but you can practice it. All right, so we're over the hour. Does anyone have any quick questions before we just call it a day here? Nope. All right, so I'm planning, even though our original schedule didn't have us meeting next week, I'll schedule a session for next week just to you know, clean up whatever, answer any last minute questions regarding the test. But the get together is going to be, let's see, we're fast approaching, right? Isn't it the 15th and 16th? So next Tuesday is the 11th. And then we get together in near between Cincinnati and Dayton there on the 15th and 16th. So a week from this weekend. So we're coming up. So by next Tuesday, be sure to have gotten through the entire, all of the chapters. All right, everybody good? All right, I'm going to go ahead and close the whiteboard and end the meeting. All right, see you guys next week. Bye-bye.
Bye-bye.